Welcome back to your mind-blowing Echo Wisdom YouTube channel. Today we have a common solution to replace a lost extremity. So, let's dive into the deep end.
Prosthetic limbs are the most common solution to replace a lost extremity. However, they are hard to control and often unreliable, with only a couple of movements available. Remnant muscles in the residual limb are the preferred source of control for bionic hands. This is because patients can contract muscles at will, and the electrical activity generated by the contractions can be used to tell the prosthetic hand what to do, for instance, open or close. A major problem at higher amputation levels, such as above the elbow, is that not many muscles remain to command the many robotic joints needed to truly restore the function of an arm and hand. A multidisciplinary team of surgeons and engineers has circumvented this problem by reconfiguring the residual limb and integrating sensors and a skeletal implant to connect with a prosthesis electrically and mechanically. By dissecting the peripheral nerves and redistributing them to new muscle targets used as biological amplifiers, the bionic prosthesis can now access much more information, so the user can command many robotic joints at will. The research was led by Professor Max Ortiz-Catalan, founding director of the Center for Bionics and Pain Research in Sweden, head of neural prosthetics research at the Bionics Institute in Australia, and professor of bionics at Chalmers University of Technology in Sweden. In their research article, they show that rewiring nerves to different muscle targets in a distributed and concurrent manner is not only possible but also conducive to improved prosthetic control. A key feature of their work is that they have the possibility to clinically implement more refined surgical procedures and embed sensors in the neuromuscular constructs at the time of the surgery, which they then connect to the electronic system of the prosthesis via an Osseo integrated interface. AI algorithms take care of the rest. Prosthetic limbs are commonly attached to the body by a socket that compresses the residual limb, causing discomfort and is mechanically unstable. An alternative to socket attachment is to use a titanium implant placed within the residual bone, which becomes strongly anchored. This is known as osseointegration. Such skeletal attachment allows for comfortable and more efficient mechanical connection of the prosthesis to the body. It is rewarding to see that our cutting-edge surgical and engineering innovation can provide such a high level of functionality for an individual with an arm amputation. This achievement is based on over 30 years of gradual development of the concept, in which they are proud to have contributed, comments Dr. Richard Brannemark, research affiliate at MIT, associate professor at Gothenburg University, CEO of Integrum, a leading expert on osseointegration for limb prostheses, who conducted the implantation of the interface. The surgery took place at the Sahlgrenska University Hospital, Sweden, where Center for Bionics and Pain Research is located. The neuromuscular reconstruction procedure was conducted by Dr. Paolo Sassu, who also led the first hand transplantation performed in Scandinavia. The incredible journey they have undertaken together with the bionic engineers at Center for Bionics and Pain Research has allowed them to combine new microsurgical techniques with sophisticated implanted electrodes that provide single-finger control of a prosthetic arm as well as sensory feedback. Patients who have suffered from an arm amputation might now see a brighter future, Dr. Sassu says, who is presently working at the Istituto Ortopedico Rizzoli in Italy. The Science Translational Medicine article illustrates how the transferred nerves progressively connected to their new hosting muscles. Once the innervation process had advanced enough, the researchers connected them to the prosthesis so the patient could control every finger of a prosthetic hand as if it would be his own. The researchers also demonstrated how the system responds in activities of the daily life and are currently in the process of further improving the controllability of the bionic hand. That's all about today's video. If you've gained some knowledge, don't forget to like the video and comment on your view. Then click the subscribe button for new updates in the research world. Thanks for watching. Have a good day.